I'm going to cut this man, don't I? Hello. Price elasticity of demand is obviously a really important concept in microeconomics. Of course, we know that demand curves slope downwards, so we know that when price changes, say price falls from P1 to P2, we know, of course, there'll be an increase in the quantity demanded from Q1 to Q2. But elasticity of demand isn't about whether, when there's a price fall, the quantity demanded rises. It's about how much it rises. How responsive is the change in quantity demanded when there is a price change? Of course, I've got a price fall here, but a price could rise and quantity demanded could fall. But how much does it fall? That's what price elasticity of demand is all about, measuring the responsiveness of quantity demanded when there's a change in price. Well, we can calculate it. We can give price elasticity of demand for an actual value, a numerical value, and we need an equation to do that. So there are two equations you can use, and I'll write them on the board now. The first equation is PED is P over Q times change in Q over change in P, where price and quantity are the original price and quantity, the starting price or quantity from which price changes. This is going to give a value which is definitely going to have a negative value. If the price rises, the quantity falls, so we're going to have a plus over a negative or a negative over a plus, so it always comes out as negative. I'm going to ignore negative values. I'm just going to treat the number from now on. So this is going to give a value, and you can input the numbers of your prices and quantities, and you will arrive at a value. But you may not have actual quantities. You may be working with just percentage changes, in which case you need the other equation, and the other equation is percent change in quantity demanded over percent change in price. Either way, you use one of these equations and you're going to arrive at a numerical value. What do the numerical values mean? Well, ignoring the negative property of the numbers, just for making it easier's sake, if the value is 0, you have perfectly inelastic demand. This is the extreme case where a change in price makes no difference to quantity demanded. Quantity demanded remains exactly the same. If it's between 0 and 1, you have inelastic demand. The price changes and the quantity demanded reacts, but it doesn't react in as big a proportion as the price has changed. So a price change of 10% might lead to a quantity demand change of 5%, and that would be PED of 0.5, less than 1, inelastic demand. If it's exactly 1, we say the demand has unitary elasticity, and demand is changing in exactly the same proportion as the price changed. A 5% change in price leads to a 5% change in quantity demanded. 1 right through to infinity is elastic demand. The demand reacts strongly to the price change. The demand reacts by a bigger proportion than the price has changed. And of course the most extreme case is an infinite reading for PED, and that's perfectly elastic demand, where there is the ultimate in responsiveness. If you've studied perfect competition, you'll know that in a goods market where there's perfect competition, any change in price, even the smallest change in price, leads to a complete collapse of demand, and that's an example of perfectly elastic demand. Let's work through an example. If we know for good X, when the price is, let's say, £10, the quantity demanded is 100 units. But when the price rises to £12, the quantity demanded, of course, will fall with the price rise. Let's say it falls to only 50. Let's work through using the equation. Now I want to leave those figures there, so I'm just going to rub out some of this so that we can work through the equation. And the equation is P over Q times change in Q over change in P. Let's put the figures in. So P over Q, price was original P, original Q, price is 10, quantity is 100. That's 10 over 100 times change in quantity. The change in quantity is 50. Right? It fell by 50. We could put minus 50, but I'm ignoring the minuses. And change in price is 2. Okay, so we've got 10 over 100 times 50 over 2. I'm just going to simplify that a little bit. Okay, and I'm going to simplify it again. And we've got 5 times 1 over 1 times 2. We've got a value of 2.5. That's very elastic demand. It implies that when the price changed, the quantity demanded in a more responsive way. And to be precise, 2.5 means that for every 1% change in price, there was a 2.5% fall in quantity demanded. Okay.